So the we'll say the title of this panel discussion is the road to commercialization of the RIS technology, and we will try to, let's say, take it from very heterogeneous and different perspectives. So let me just introduce all the panelists today here connected to this webinar. We have Professor Luca Sanguinetti, full professor of University of Pisa. Luca, are you there?
Yes, I'm here.
Thank you for joining this session. Then we have Monsen Khalili, sorry for my pronunciation, senior lecturer at University of Surrey. Monsen, are you there?
Hi, Vincenzo.
Hi, good morning. Thanks for joining the session. Then we have the third one is Sergio Matos, assistant professor at the University Institute of Lisbon. Sergio, are you there?
Yes, I'm here. Can you hear me?
Hello, good morning. Yes, thanks a lot for joining. Then we have Youssef Nasser, 5G and 6G business light tech at Greener Wave, one of our partners of the RIS project. Hi, Youssef, are you there?
Yeah, hi, I'm here.
Hello, good morning. Thanks for joining. And then the last one is Dintui Panui, research project manager at Orange Innovation, also a partner of our consortium. Hello, Dintui. I think you are there. Yes, I saw you before. So thanks a lot for joining this interesting panel. Today we have a set of questions, so let me just go through them. And then since, of course, we have very stringent requirements on the time, I would just ask you to take, each of you can just take 2 minutes per question to provide an answer. And then, of course, I will just try to raise my hand whenever, let's say, you are close to the 2-minute limit. But, you know, let's try to have a kind of interactive session. So let's start from the first question. What key trends and innovation do you foresee in the near future that could significantly impact on the commercialization of the RIS technology? To this end, would RIS enable smart wireless environment contribute to this new concept called ISAC, integrated sensing and communication, that, you know, as you know, it's really coming and taking, you know, all the momentum right now. So I would just start from the Professor Luca Sanguinetti. Please, Luca.
Thanks, Vincenzo, for the invitation. So regarding the first question, so as an academic, so in my view, there are different applications and trends that can benefit from the RIS technology, and of course, the internet sensing communication is one of them. I mean, if we can really deploy a smart wireless environment that can actually sense the environment and then help the communication and sensing capabilities of the network, this is probably, I mean, one of the way to commercialize the RIS technology, to make the commercialization of this technology very successful. From a technological point of view, I think as researchers in this field, we should still try to understand what are the limitations of the technology, in the sense that we're seeing this technology as a very so first of all, in my view, we should try to understand how to control this technology in an energy efficient way, in a dynamic way, and most of the cases in a distributed way. So which might be the way to make it very attractive for the for the implementation of the technology in a very, let's say, plug and play way. I think we're making progresses in this respect, but I still believe that there is a lot to do and a lot to understand, especially in the way to control this technology in a dynamic environment and to make it very power efficient. This is my
Okay. Thanks a lot, Luca. Thank you. Then I would then ask the same question to Mosen.
Yeah, thank you, Vincenzo, for the invite, and also thank George for organizing this informative workshop. So basically, because RIS is a nascent technology and perhaps is too early to discuss about the future of RIS, but it's received a lot of attention from the wireless community. And the main things we need to consider is how we are going to deploy this RIS in real network for 5G or 6G. So one of the main issue or one of the main challenges about RIS is the power and its interference management between RIS and also in one cell. And if one of the innovative things can be used for RIS in future is to have innovative material in terms of low loss or new switches to have a dynamic RIS. About the ISAC, we have two trends of ISAC. Is like if you do joint or integrated sensing and communication over one frequency or over two different frequencies. Some they believe that okay, let's use higher frequency for sensing and lower frequency for communication. But some believe that because licensing is expensive, so it's better to have ISAC in one particular frequency. So RIS can do both of the can operate for both scenarios. We can come out with one RIS at a surface that it can sense and also it can do the communication. The communication part is a reflection type or a star type or whatever transmissive. Different type could be. But in terms of sensing, one way is to joint like radar or other technology with RIS. But we prefer to have a RIS on itself to do the sensing as well. So and the problem is we need to come out with we need to come up with a solution to how to maintain the price of the RIS. So if we can come out with a material, different materials, like new type of switches, new type of substrate with a different thickness, it could be affect the future of RIS.
Okay, thanks a lot. I would then ask the, let's say, last panelist from the academic world, which is Sergio, if you can take the first question.
Okay, thanks a lot. First, I want to thank George for this kind invitation. So as you mentioned, I'm from academia, so talk about commercialization from academic is always to be skeptical. I will give my opinion anyway. So just to give you my background or why I'm here. So I'm also involved on Terra Meta project as the work package leader for hardware. So I'm usually the pessimist of the group. I see that my fellow panelists are a bit on the same trend, but I will focus a bit on the question regarding all the challenge that I think we have time to discuss. I would say that from a commercialization point of view, I think ISAC, so the integrated sensing and communication, is actually an opportunity because I believe that the telecommunication providers will be a bit slow to absorb this solution because it's still a very high risk investment. This is a disruptive technology and it still has a lot to show. So it's better to have a broader, wide range of markets that we can reach. So this is where I think ISAC is a good approach to push for the development. So and I think this could be a way of start jumping the technology. So in terms of innovation that I can foresee to allow this technology to grow. So I think it's basically the two main points are about cost and about deployment or integration. So in terms of cost, there is the ongoing, as we saw in the previous presentation, effort of using millimeter wave communication. This is pushing the electronic technology forward. So this means that the available electronics will hopefully lower their costs and provide better solutions for us to have a lower cost implementation. So this could be a trend that is occurring, and hopefully will help the development of RIS. Another aspect I think it's important is the fact of the integration of RIS, not only about the deployment for optimization of the network, but also to do it as a seamless possible way. We know that there is always implicit fear about seeing the antenna itself. So when we're talking about changing the environment and deploying systems, we need to make sure that we are not creating strange elements that will be not well foreseen by people. So this will put away people from this solution. So one thing that I think that needs to be accounted is a bit the aesthetics of these components as well, should not be overlooked. And this raises a very important challenge for material science, where I think innovation should come as well to push the technology forward. I think that resurface built on flexible, transparent materials that could conform to any shape could be an enabling technology to overcome these limitations that we should account it already in this design phase, because this is all about hardware. So we need to start already thinking about the materials that we want to use and can be commercialized. So we should not put these two things so far apart as sometimes is done in other topics.
Yes.
Yeah, this is basically.
Thanks a lot.
Thank you.
Thanks a lot for your very interesting answer. So then I will just ask Youssef if you can share your comments for this one.
Yeah, do you hear me?
Yes, please.
Okay. Yeah. Yeah, good morning, everyone. Actually, I prepared some slides, but maybe I can do with other slides, or I can show the slides afterwards.
Yeah, we should just
yeah, it's fine. It's
keep
fine.
within 2 minutes.
Yeah, indeed. The format is not. Yeah. Anyways, key trends, innovations. I think my colleagues have stated many of these things. I would say the key trends, innovation, there are in two parts. The first one is power consumption, and the second one it's the cost. Okay, I mean, if we want to have a RIS technology that is commercialized, I think we need to work on these two. The other point that my colleagues worked on or talked about, which is the deployment or the interference management and stuff like that, I think we have maybe some available technologies that are being there or can be developed. If we don't solve, to me, the two bottlenecks, which is the power consumption of RIS to be, I would say, autonomous, and the cost of the RIS to be comparable with existing solutions, then we cannot really move forward. And what I have in mind is mainly this NRC or the repeater, actually the NCR, sorry, non-controllable repeaters. The idea is now, if an operator would like to deploy RIS, then the first thing that it would come to the mind is, what would I benefit from if I use the RIS instead of the repeater, whatever the smart repeater. And then the first thing would come is how much do I need to pay in terms of power, in terms of cost. This is the main important point to me. Yeah. For the other parts, I think there are solutions. Don't worry about that. And this is where we are in RenoWave. Actually, we are developing because we are tackling these pain points from a user perspective. And by user perspective, I mean operator perspective.
Great, thanks a lot, Youssef. Then last panelist is Dintui, please.
Thanks for inviting me to this panel. So Orange and Telecom Italia Mobile, actually we share the same view, and it's very similar to the one of the previous speakers. We stick to the idea that the RIS is a promising commercial technology to serve as a passive relay, especially in indoor where there are coverage holes, and mandatorily if it costs orders of magnitude lower than a true active relay, and if it's much easier to deploy and consumes order of magnitude less energy. And I think RenoWave is showing with its prototypes the right direction. I also know from discussion with my colleagues from SNCF, the French train station partner, who allowed us to make these trials together in Rennes, that they think, of course, of using these passive relays for connectivity inside the train stations to avoid these big obstacles, such as indoor shops, like it has been done during the trial. But they are also thinking about using train windows to relay signals inside the train for onboard connectivity. Regarding the ISAC commercialization, for the moment, Orange, and we know from our colleagues from Telecom Italia Mobile as well, we have the same position. We are both involved in a EU project called 60 DISAC. It's about ISAC. And we participate to it with Chalmers and other partners. So we are kind of following the subject. But last year already, Orange has shown some potential commercial usage of RF sensing integrated with data. In 2022, we've shown that the Orange Wi-Fi box can detect intruders in customers' homes, and we think that there is a potential commercial interest for that kind of service.
Okay, thanks a lot. That's very interesting. Then let's move to the second question. How relevant are the current standards to the RIS technology, and which are the necessary elements for the technology standardization? Can this be considered a showstopper for such an emerging technology? I would just start now from Sergio. I would like just to ask you, all the panelists, if you can just try to be within 1 minute and a half and 2 minutes, otherwise we'll not be able to let's say, go until the end of all those questions. So please, Sergio.
Yes, so I'll keep it short. So I think RIS assumes here the working principle to deploy interoperability between different scenarios, so and mobile users. So without some standardization, this will not be possible to do. So instead of saying this is a showstopper, I would say that this is of paramount importance to find good standards. There are so many standards right now, but I think the technology itself lays for other type of standards. One example, just to complete my intervention, is the fact, for example, when you want to build something, you usually have certifications for different type of things, but for the telecommunication point of view, it starts to make sense to see what materials would be more effective for the deployment. So this is one example where the standardization could really help the deployment. So this is one point.
Thanks a lot. Then I will ask Mose, since I think you're also part of this RIS group. So please.
Yeah, basically in RIS SIG group in ETSI, we have actually conducted 6 work items led by different like university and also companies. So the one I'm leading is about practical consideration of RIS, because as you've seen, there are a lot of study around RIS, and you see every year there are a lot of publication about RIS, but they miss the main point of how we are going to deploy the RIS in real network. So there are very good activity in ETSI, and we welcome all the university and all the companies to bring us and to contribute different contribution. We aim to also go ahead and try to participate in 3GPP in perhaps in 2024 or maybe to early 2025. And we also publish several reports from the first 3 work item. I think you also been involved in, you also led one of them. And in a standard, what we try to capture all the relative literature review, and also we try to identify the roadmap KPI for the future of RIS in terms of the system level, also the practical consideration, channel modeling, channel estimation. And I think there is a very good activity in HC. Hopefully, we can do the same job with 3GPP in future.
Thanks a lot. Yes, GPP should start this new study item on ISAC and hopefully soon also on RIS. Then I will move to Luca.
What I agree that this is probably it's not probably the showstopper, but that's what we really need to push the technology. So if we can standardize the way the technology is going to be implemented and used in different scenarios, this will be the way to push the research towards the right direction, and I think is very much important instead of being a showstopper. Of course, the interoperability, privacy, security issues, these are things that should be addressed, but I think we can address these points, these issues, if we can see the potentials of the technology to the different standards.
Okay, so I would say from, let's say, the academic perspective, you see this technology is still a promising one, even though now let's say we should start looking into some implementation issues. So now let's see what the, let's say, industry thinks about that. So please, Dintui.
Yeah, thank you, Vincenzo. So the technology does work without the network participating. We've shown it on the field trial in REN station. You already observe gains, but we share the same vision with Telecom Italia Mobile and Orange, that it's better to have a really joint optimization of the base station, what does the base station, the UE, and the RIS together, thanks to a standard. Because as you have seen during Work Package 4, 5, 6, the technical Work Packages, most schemes exploit very fast, very important interactions between the base station, the UE, and the RIS. And therefore, we consider that it requires, to be the best exploited possible, it requires standardization, and the standardization of control channels, of interaction with the RIS controller, the RIS orchestrator, etc. And of course, ETSI ISG RIS group is a very nice place today to get consensus between companies and academic labs, with the help of academic labs on these aspects. I want to mention also two other aspects that are different from protocol aspects and architecture aspects. It's bandwidth of inference and area of inference. As an operator, we invest quite a lot of money into spectrum, and we are happy as long as spectrum coexistence between the operators is respected, is kept, is ensured, guaranteed. We believe that the RIS technology has to be kind of rules have to be defined to make sure that this spectrum coexistence remains. And there has been some work on this bandwidth of influence that has been shown by Mauricio. It is the bandwidth, the spectrum over which the RIS has an influence. It's sometimes for some implementations, it's much bigger than the spectrum allocated to one operator. And it has been discussed, defined, and characterized for several types of prototypes inside this ETSI ISG RIS group, which is really a good progress towards standardization. And Orange has participated to this characterization with its own RIS prototypes of 96 unit cells and 984 unit cells for 5.2 gigahertz. And second point is, when you work on performance at the 3GPP, you have to align on basic concepts, which are coverage and capacity. And what is needed today in standardization is to have this concept of area of influence, which is the area where the RIS has an impact on existing service of coverage, whether it is localization service or something else. So it has been shown by George. This has to be used as a concept in a standardization when it comes to performance assessment. And that's all from my side for Orange and Telecom Italia Mobile. Thank you.
Thanks a lot. Then Youssef, please.
Yeah, I will try to make it shorter than Twi.
Sorry. Sorry.
Thank you. No problem.
Yeah, I don't think that the standards is really a showstopper for the technology. Far from beyond that. Far from that. What I really believe that the standard will make a certain kind of consensus of on the technology itself. This is one. Two, and as Dintwi said, in some places there's really agnostic to the operator. I mean, you can deploy the operator, the RIS without any problem on maybe neighboring operators or neighboring cells. This means that we can do some tests, some pilot projects with the RIS without any problem. But does not mean that we don't need the standards. We need some standards just really to make sure that everything is aligned, everything is well done. But I think it's just a necessary step, but it's not a blocking step. This is my feedback on this.
Thanks a lot. Of course, here the question was more on the 3GPP standard that usually is considered one of the real standard for proceed with all the implementation. But thanks a lot for all the panelists. Then let's move to the third question. Which are the killing commercial applications or utilization of RIS with respect to different frequency bands? Now I would like to start from Youssef, please. Since you were the shorter one, you can take it.
I think it depends on so many inputs. I mean, the commercial applications. Actually, the discussion that I've had with many stakeholders on different aspects is the coverage and the capacities are to me the main ones. And then I would add to this something related to Isaac. Okay, Isaac maybe would take some time. At least now the current applications, or it's not application, and maybe it's use case. It's it's a deployment use case. It's capacity and coverage, and it depends on the frequency. If we're talking about FR2, differently we're talking about coverage. If we're talking about FR1, we're talking about capacity, and then we can separate between indoor and outdoor environment. The other question that I would maybe raise is not only related to the killing application, but also what would be the stopping application to this RIS to be deployed. And one of them, maybe I'm against, didn't we, on this deployment of RIS for trains or inside trains using Windows, because one of the key questions here is the I would say the OpEx of this deployment. For instance, we're talking about a glass or like RIS or lens like RIS. Then who's going to deploy this? Who's going to pay for that? Who's going to pay for the repairing if there is any
just
problem?
to precise that this is SNCF. SNCF use case, not Orange.
I mean, just giving
Yes.
I mean, we have many questions that should be raised on that perspective. Okay, I'm not to talk about against you, far from that. It's just to say that there are questions on the RIS deployment that need to be raised from a perspective of I mean, user terminal or end user use cases. Definitely scenarios like indoor, like stadium, where you have plenty of users, then the capacity again plays a role. Then the RIS deployment would be beneficial in this environment. We forgot one important point in the workshop, which is beyond 5G or 5G advanced, which is Wi-Fi as well. With Orange, we have a project also on RIS for this Wi-Fi deployment. And I think also it's one of the use cases that we need to look at, and this concerns the sub-7 gigahertz, and the 60 gigahertz Wi-Fi deployment. Yeah, this is my two dots on this questions.
Thanks a lot. Then Dintui, please.
Yeah, thanks, Vincenzo. So after 3 years on this project, so we realized that probably the killer commercial application number one, the one to start with, is really this millimeter wave coverage improvement. And we share this vision with Telecom Italia Mobile and SNCF, this low-cost, low-power solution to solve this problem. With Telecom Italia Mobile, we realize also that you really need to be very careful about when to and where to deploy RIS. Vincenzo have shown some ray tracing simulation showing exactly where you can boost the performance. So you won't deploy massively RIS at random. You have really to pick the right locations. And also SNCF is thinking that it's useful for some very big and complex buildings they have, like train stations, but also train depots, industrial depots for train. And also they think of using it to help implementing geolocalization functions for SNCF applications, thanks to cellular networks. So this is the vision of Orange, Telecom Italia Mobile, and SNCF.
Thanks a lot. Actually, we also did another recent study with the Telefonica, where we show the total cost of ownership, just from using real data set and how the RIS would impact the overall cost of ownership compared, let's say, to the performance. But it's another story. Then I would like to ask Luca to answer to this question, please.
I think that the coverage and capacity are basically the two different, I mean, the main applications for the RIS technology and for millimeter wave bands. And if you want to move towards the sub-terahertz bands, this is probably one of the way to use the technology. For example, I'm leading 6G SNS project in Times, which is about using the RIS technology in industrial environments. And this is probably one way to make use of this technology. When you have a very controlled environment, indoor environment, you can place the RIS wherever is needed to improve the coverage, and especially when you move up in frequency. And this I think where the technology may help in the design of the network.
Thank you. Then Sergio.
So I would say that this is literally the $1 million question. So it was very difficult to the killer commercial application, at least. I see that the extension of coverage is the most obvious one, but probably this won't be the killer one, right? So it's still quite focused market, let's say. So probably the killer commercial application is yet to arise. But my feeling is that will come from some merging of different income development of technology like IoT, 5G. So something that RIS allows to augment it and interact with people. So in order of looking at this with different frequency bands. So if I'm going to lower frequency bands, my idea is that RIS can act as a way of improving smart sensors. So it's basically merging ideas, not competing ideas. Actually, this discussion that was emerging about relays and RIS versus, for me, it does not make much sense, because actually at some point this is a really good relay because it's low cost, or it's because it becomes just a name, because the technology will influence each other. So the RIS can be part of a relay, the relay can be part of the RIS, as we're discussing, and the development of these things will feed other technologies. So I would, for me, a killer application, but this is like fiction science, is to walk in a city or in a smart city and start to have some augmented capacity. So I would be able to interact, to see objects. We need to think a bit more ambitious in terms of users, because this is what will appeal for people. Because if you say that we are improving just for the operators, maybe it will not be the killer one, because operators can always find a technology solution that can benefit for even having passive things more with a lower cost than active things. So I would think that the killer application should aim more ambitious.
Okay, that's very interesting viewpoint. Thank you. Then Mosen.
So very straightforward answer is, of course, the coverage enhancement. So what I mean from the coverage is not voice coverage, is a meaningful coverage. So meaningful coverage means that when you are like moving around like one city, like London, for example, sometimes you have voice, but you don't have data, or you have data or you don't have voice. So it means that any user should have access to any type of services. So RIS can like create this kind of actually coverage by enabling non-line of sight communication, especially when you go to higher frequency band like millimeter wave or sub-terahertz band for, let's say, future. So the main the main application of RIS is the coverage enhancement by recycling this electromagnetic wave. But depends of the type of RIS. For example, like if you have a transmissive RIS, which is now recently received a lot of attention by covering the windows, you can enhance like the 5G signal in indoor, but at the same time, you can stop leaking Wi-Fi to outdoor. So that would be another nice and like practical application of RIS, because if you try to block Wi-Fi leaking out from your building, you try to enhance your Wi-Fi service inside the building, and also you try to enhance your security. Like another use case or another application would be stories. Like if you consider the stadium, you can provide arbitrary beam shape for the people who are sitting around the field. But what I mean what I think the main application would be in indoor coverage as well, especially for private 5G, because for the future question we need to discuss about the challenges. I will raise some challenges, but these are like the things we can see from what we can do now. But there are also a lot of discussion about satellite communication, about vehicular communication, about RIS, talking to UAVs. These are like something perhaps or we need to do more investigation. But the main thing of RIS is providing the coverage first. Then later on, if we solve the deployment problem and a lot of challenges around RIS, we can bring them to the factory, which you have a lot of metallic, which act as a PEC, perfect electric conductor boundaries, which you have a bunch of multipaths in one environment, and we see how RIS can provide the connection between, let's say, robots or machines inside the factory.
Okay, thanks a lot. Then let's move to the fourth question, which is very, very interesting. Which are the most important features you would expect to have in RIS that are not developed by today? For this, I would like to start from Sergio.
So I would say I already mentioned a bit. Also, it was mentioned in the morning presentation about the fact that the conformal approach would be a quite interesting feature. Usually, this is very flat panels. Some investigation has started, but actually, if you want to make this more easy to deployment, the shape factor should be a content, which brings a lot of challenge, but let's stick what we want to have. Another thing that was mentioned in the presentation was the real-time computation capability. So we're using hardware to make some calculations. Could be used, for example, for encryption or other functions that could be useful. So this also is being investigated, and it seems very promising to me to enhance this technology. Another thing that could or makes a lot of sense here is using this surface as well as for power harvesting. Could be solar, could be millimeter wave, but it's somehow a way of counteracting this power consumption and mitigate it. So again, all these features will imply a new redesign. So again, it's good to have already a good idea where to look, but for sure would be very nice to have these hybrid cells that collect energy as well as correct phase. It could be a different frequency or not, but there's a lot of options. Well, I could go on, but maybe I will leave to
I
my
think
colleagues.
your answer was quite clear. Thanks a lot. Then Luca, please.
So, I mean, the self-learning capabilities is probably something that I think is very much important. As I said, I mean, this technology may, I mean, if we can develop this technology in a plug-and-play manner with self-learning capabilities, very dynamic in terms of auto configuration, this might help in using it in different scenarios for different frequency bands and so forth.
Thanks. So I don't know if you know, but we've been working a bit on this self-configuring RIS. This was an Infocom a couple of years ago, and then we are also now working on a real prototype where we can really try to implement a self-configuring RIS. But I mean, I will send all this detail later on. Then I will ask Dean Tui, please.
So what are the most important features that are not developed today? So
Exactly.
with Telecom Italia Mobile, we have an operator answers. We have no strong opinion on the features, but we have very strong opinion on the requirements. So requirements that are missing today is please imagine, build the features that will make RIS not messing up the spectrum. First requirement. Second requirement.
So you mean a very limited bandwidth of inference, right?
Oh, coordination. I trust you to find it. There are on the call a lot of people with a lot of imagination. Whatever
Yes.
the solution, to make sure that operators don't mess up with the spectrum of one another. It can be coordination, it can be avoidance, whatever. It can be in the base station, in the UE, in the RIS, a split over the free. We don't care as long as it works. The second requirement, it comes from my colleagues from Telecom Italia Mobile, and I share their view. Please make sure we have a control on the shape of the reflected beams. We know it. We know what it's doing. It's not completely out of control. So these are the two requirements: spectrum and spatial, I mean beam shapes. Thanks. That's all.
Thank you.
If I can make a comment on this, I for example find very interesting the way we model in any communication paper. We model the system with so the RIS is basically a noise-free element, which makes sense, but in the end we have interference coming, impinging on the RIS and being reflected somewhere. And I think this is something that we are not looking into we are not looking into in most of the papers, in most of the literature that we have in RIS. So it's basically something noise-free, which makes sense, but the interference will always be there, will always change the impact the performance of this.
Thank you for raising that.
network.
It's exactly the kind of requirements or problem or challenges we would like the research community to work on. It's imagine this being deployed for real.
Exactly.
For real, I mean, without simplifying assumptions. Thanks. This is the next step.
That's a very interesting point. Thank you. And then I would like to ask Youssef, please. Hello, Youssef. Are you still there?
Yeah, sorry, I was muted. Sorry.
Other one.
Yeah. So what I was saying is that I have many inputs on this question. The first one is, and allow me maybe to comment on didn't we last comment on this spatial control? Yeah, I think it comes by its own, at least from RINR wave perspective, we have this controller. However, where I agree with you actually on this is that we need to have this control as real time as possible. This is one, that's first input, and the level of integration of this autonomous calculation computation should be on the RIS. So the integration should be an integral. I mean, the integration should be there on the RIS. Shouldn't be a side controller. As much as we made the controller close and integrated to the RIS, the better it is, because this will allow us to have a better control. That's one, and will allow us to avoid interference with, or at least to manage the interference, to manage the beams. I think so far we have some of these algorithms, but they are still not integrated in as a full solution. And the rest, we're still talking about prototypes, right? This is what we are trying to do in our next generation of RIS. So integrate everything on the board of the RIS, and this will help a lot, because this means that we need to integrate certain level of 5G protocols or other protocols to have a full control of the RIS, and then allow all the potential of the RIS. And I think we need some extra steps on that.
Thanks a lot. And then last one is Mohsen.
Yeah, so this question is very important, because I think there are some, I don't call it challenge or drawback, I'm calling research gap in terms of risk.
Yeah.
One of the things is interference due to the high specular reflection from the risk. Some researchers try to use this specular reflection for NOMA or like getting diversity, but this caused the interference within one cell between two operators, because the bandwidth of this, let's say 5G bandwidth, the chunk of the bandwidth are very close. Imagine you have two operators in one cell, and one of the operator has a very good coverage and another one has a poor coverage. And the one who has a good coverage does not need to like get a reflection within the actually the cell. Another problem is the power, because if you want to really have a proper RIS which can do azimuth beam shaping and also elevation, we need to have access to the phase response of each individual element. And if you have, let's say, a RIS with 1,000, the minimum 1,000, because RIS has a very limited efficiency, so you need to get a larger aperture to solve this, or perhaps add some active elements like transistor to boost up the signal at the surface. Anyway, so the problem is the power. If you want to like handle, if you, let's say you have 1,000 elements and you have you need to control both polarization, so you need per minimum you need 2 diodes for each polarization, so you need 2,000 diode or switch, which require a lot of power, especially for the dynamic. And if you want to have a like deploy it in outdoor scenario, is also difficult to where you are going to like deploy the RIS. So one of the things would solve this problem, perhaps if we go for new type of material, which you can once just manipulate the phase and leave it to make it fix as a like a semi-dynamic. That could be one of the solution, because what I believe, especially when you go to higher frequency, at 3.5 also is fine. You know where are the blind spots, and you rarely need to dynamically change the beam. A very like maybe very specific scenario, you need to use the dynamic RIS. So if we can come out with some approach to get one semi-dynamic RIS, that would be a good solution for future, because you can tune the response to the based on the requirement of that sorry, environment. And so these are the two issues. We need to come out with algorithm, we need to come out with the materials and blah, blah, blah. And in terms of the power, there are some study, like there are some autonomous or free power RIS, which some people, they use the RF energy harvesting, some people, they use the solar cell. But these are like the merging technology. But because when we are going to deploy the RIS, we prefer to have a RIS with less, like we don't want to have a complicated system. That's why we try to avoid using even the RF chain. If we want to add the RF chain, because RF chain is require a lot of power, is also costly. So basically, I believe that if we can come out with a solution to bring down the power as much as we want, as much as we can, because if you have 1,000 elements, as I said, you need around 100 or 200 watt for like controlling both polarization just for a simple 1-bit metal surface. If you go for 3 bits, so you need more and more diodes.
Yeah.
So that's the two major points I need to raise.
Thanks a lot, Mosen. I think it was very interesting discussion. Then let's move to the last question, which is, let's say, regarding this societal impact. So can you, or have you already identified any ethical or environmental concerns associated with the industrial application of RIS technology? And if so, how should they be addressed? I would like to first know, let's say, the academic perspective on this. So let's start from Luca, and then we move to industry.
Sorry, I was muted.
No problem.
I can probably, I mean, probably the most obvious environmental concern is the power consumption. As we have said many times, if we can control this technology with the low power, I mean, this will help the implementation deployment of the RIS technology. If not, this is gonna be a showstopper for the technology itself. And to my knowledge, I mean, there are many different solutions, but it's not clear yet how to control very large, as has been said, very large RIS with many elements in a dynamic environment with very low power and with just a few bits of signaling. I mean, just yeah. And this, I think, is the most important aspect from an environmental point of view.
Yeah, thanks a lot. I fully agree with you. Then, please, Mosen.
Yeah, so because these surfaces are large somehow, if where we want to locate this, usually people are in near field of this RIS. So that we need to like do some network planning very carefully, because although RIS is not generating new electromagnetic wave and it's just reflecting the wave, but still due to this large aperture, when you are in near field of the RIS, it may cause some like exposure, and that would be that we need to sorry, measure this exposure due to RIS as well. And another thing is, like, when you are going to deploy RIS in different location, you need to see where
I think we lost you, Mosen.
Yeah, this
Are you there?
Portuguese.
You went to lunch.
Automatically.
I don't think so.
Okay, then I will just move to Sergio, and let's see
Yes,
if he
so
can join.
unfortunately, I cannot hear the finishing of this. But there was, let me just comment 2 points, because it's, after all, is a discussion. So the point of non-volatile switch is something that actually we are working on Terra Meta. So we are very aware of this problem, including the number of switches that can be optimal for configuring the surface. As for the near field, is another problem that we are also thinking about, because in fact phase control can also be applied for near field beamforming, so but usually requires more bits, so it's a quite difficult balance to reach and challenging for sure. probably our solution between passive and active. So everything it's being considered right now, looking at this limitation, but definitely something to consider about. Now, in terms of the question itself, when I was thinking about this, I want to point out this also quite important limitation or concern that I have, because when designing antennas, we started to get some feedback for companies in saying that we need to start using other materials, because there is legislation coming from that are preventing of using some polymer-based materials due to their impact and recycling capabilities. So we are designing all these things with very precision and very carefully, but at the end you can end up with a very non-friendly solution. And this brings us to the blackboard again. So again, this is a big concern of mine about the materials that we are using. This is one aspect. Also, the aspect of security, I think it was mentioned a bit on the presentation in the morning, is another important feature, because if one wants to use a passive, let's say that we have finally a low-cost solution for deployment this, so everyone can get one and interfere and attack, and so this is very difficult to and should be accounted on the design of the system. So cybersecurity needs to be real dealt here as well. So, but the problem is it's at hardware level, and the things become more challenging than that. And of course, there is always the problem of doing this sensing is about we are invading personal space maybe sometimes. So there is a confidential purpose. So this could be entering some legal issues as well. So there's a lot of problems, even if we deliver what we are promising. There are other problems that we probably should already be thinking about as well. So as I was saying in the beginning, I'm a bit pessimistic. Some regrets.
Definitely, I agree with you. Thank you. Mosen, are you back? Are you there?
Yeah, I do apologize. I lost my connection.
No problem. If you want to
just two things
conclude,
very briefly. One is the EMF due to the RIS, and another one, the RIS should be user friendly, because if you are going to have like a bulky structure to deploy in indoor environment or outdoor environment, you should be careful about like the people point of view, whether they like to have this RIS around themselves or not. So very briefly, thank you so much, Vincenzo, for arranging this panel.
No problem. Thanks a lot for your availability. Then let's move to the industrial panel. So let's start with Youssef, and then we move to Dintui. Please, Youssef.
Yeah, thank you, Vincenzo. To me, I agree maybe with some concerns that have been raised. I will not really contradict this, but I'm maybe a bit more optimistic, and as from a business side, I think there are more opportunities with the RIS in different scenarios, different environment than or ethical and environmental concern. There are some concerns, definitely, and my colleagues have talked about this. And let me maybe raise two opportunities rather than two concerns. The first one is, I mean, with the RIS, if I compare a RIS with NCR, for instance, we can compare with the power consumption, for instance, and then the environmental concern for NCR becomes an environmental opportunity for the RIS. And then from this perspective, then yeah, we need to compare with some other solutions. This is one. My second point would be concerning sensing and beyond sensing. We're talking about maybe vision. I mean, we're talking pretty much about sensing, but we can talk about vision with large intelligent surfaces, and this will give us different use cases, different applications that have some ethical issues maybe, but also they solve other ethical issues. So if I want to deploy, let's say, a RIS to just very simple example, to detect if there are any available people in a room, or I need to deploy camera, for instance, I would go with the RIS rather than to go into to camera because it's not intrusive. So there are some concerns, but I see them more as opportunity that we need to use them. And with this, I need to conclude with two important points. The first one is we have a European project called Converge, and it's shared by one of the tasks by my colleague Ahmad Chouchef in Wave, on which we're combining actually computer vision and RIS and communication. So all of this are combined. And this the other project that we're working on is going to start soon. It's instant also. We're talking about Isaac using this. So all of this, if we put all to this together, to me, this will be raising some issues, but at the same time raising also some opportunities. And we need to. I'm someone positive. Maybe we need to look at the opportunities on this use cases. Thanks.
Yeah, thanks a lot. I agree with you. You know, usually problems help because then you can find solution.
Yeah.
Then Dintui, please. You are the last one.
Thanks, Vincenzo. So for Orange and Telecom Italia Mobile share the same view. The RIS is kind of the most environmental and societal friendly radio equipment, indeed, because it does not radiate anything. So acceptance or adoption by the general public will probably be much easier. Actually, we call it electromagnetic field aware radio technology. And still there is some work to do regarding the design. So there are two strategies. Either you make it invisible, so you put it inside panels or behind screens, etc. Or like SNCF suggested, because they have to deploy it in a train station, you work on iconography and notice boards, explaining to customers what is this device, what it is doing, so that it's part of the environment and it's considered as friendly. And last thing, it has been said by one of the speakers, we believe that it's an equipment that could be partly reusing existing material. For example, Orange 2 first prototypes, the one of around 1,000 elements and the one of around 200 elements, they are both actually refurbished antennas, truly active antennas, which have been turned into RIS. So we have minimized the impact on CO2 emissions even during the design process. So to sum up, I think it's quite potentially a quite environmental and societal friendly radio equipment. Sorry.
Yeah.
Thanks.
Thanks a lot. Thanks a lot, Dintui. So I fully agree with all of you. I would like, first of all, to thank the panelists, to thank all the organizers, to thank all the speakers today and all the attendees for this nice and very interesting workshop from RIS-CG project. Basically, you know, it's just the end of this workshop. As you know, we have been working very hard in the last 3 years, really to strengthen the leadership of Europe for this, let's say, sustainability race. Because at the end, even with the RIS, with smart surfaces, we want to provide a new tool, a new means, a new technology towards new future sustainable networks, wireless networks. So this was our main goal, and I think at the end we really try to put a very small piece into this big picture. Let's see if RIS will be also a key enabler for this new emerging topic called Isaac, as we expect, as we envision. But at least we can say that with RIS we had a lot of interesting discussion, interesting activities, and we could really validate, demonstrate how the RIS could be directly involved, installed, and exploited within real scenarios already today. So thanks again, all the speakers, everybody to be here today. If you want to get more information, here you have the website. There are all the deliverables. There are all the huge number of publications we did during those 3 years. And soon we'll also publish the 2 videos for our field trials activities. So thanks a lot and have a nice day.